Namaste dear students, welcome to your channel Virtual Master. We are starting a new course on class 11 physics and this is the first video of our course. The course is designed in such a manner that it will be useful for both board exams as well as the competitive exams such as NEET and JEE. We are starting from the third chapter of class 11 physics, that is motion in a straight line. In this video, we will be discussing about mechanics and its branches. Also, we'll be discussing about few basic terms related to mechanics, that is position of an object, definition of point objects. Also, we'll be discussing about the rest and motion of an object. At the end, we will be covering frame of reference. Watch this video till the end. At the end of this video, I'll ask one question for which you have to give the correct answer in the comment section. Okay, let us start with our first topic, that is mechanics and its branches. Now, what is mechanics? Mechanics is one of the branches of physics in which we are going to study about the motion of an object under the influence of forces. As we all know that objects are non-living things and they cannot move on their own. So what we have to do? We have to apply some external force, right, for its motion. So we will be studying the motion of an object under the influence of force in mechanics. And there is one special case also in which even after applying the force the object will not be moving. That special case will also be studied under mechanics. So mechanics is again divided into two branches. One is statics and another one is dynamics. And in statics we will be studying about the object at rest. Whereas in case of dynamics, we will be studying about the objects in motion. In statics, we will be studying about the object at rest. That means they will not be moving, objects will not be moving. That case will be studied in statics. Whereas in case of dynamics, we will be studying about the objects in motion. Now, dynamics is again divided into two branches. One is kinematics and another one is kinetics. In kinematics, we will be studying about the objects in motion without considering its causes. As I have already told you, for an object to move, we have to apply some external force, right? That external force is nothing but the cause of the motion. In kinematics, we will be ignoring these causes, that is, we will be ignoring the force factor and we will study only the motion of an object. Whereas in case of kinetics, we will be studying about the motion of an object considering the causes. Okay. In kinematics, we were ignoring the causes. In kinetics, we are considering the causes of the motion also. So the difference between kinematics and kinetics is, in kinematics, we are ignoring the cause of the motion. Whereas in kinetics, we are considering the cause of the motion. Our chapter, that is motion in a straight line, comes under the branch kinematics. Okay, let us study or discuss about the kinematics. Kinematics is derived from the Greek word kinema, which means motion, and matics means measurement. The name itself gives the definition of kinematics, that is measurement of the motion. Okay, as we have already discussed that kinematics is the study of motion of an object without considering the causes. Okay, for our syllabus there are two chapters under the branch kinematics. One is motion in a straight line and another one is motion in a plane. I hope everyone have understood the definition of kinematics. So let's go for our next topic, that is position of an object. Now what is position? Position is nothing but the address or location of a particle at any instant of time. What is position? Position is nothing but the address or location of a particle at any instant of time. Now the question arises, how to describe the position of a particle? To describe the position of a particle, we need one reference point, and also we need the distance of the particle from the reference point as well as the direction of the particle from the reference point. Okay, to understand this better, let us take one example. Let us assume that our home is located in XYZ colony and it is near to the park. And as per the figure, your home is located at a distance of 100 meter from the park on the right side of the park. Now, if someone asks you the address of your home, how you are going to explain, how you are going to tell the address of your home? We will tell that in our colony there is one park. On the right side of the park, our home is located at a distance of 100 meter. Okay, here what we are doing? We are taking park as the reference point. From this park, your home is located at a distance of 100 meter on the right side, isn't it? In a similar manner, to describe the position of any object, we need one reference point, and then we have to describe the distance of your particle, distance of the particle or object from that reference point. Also, we need to tell the direction of the particle from the reference point. I hope you have understood the definition of position and how to describe the position of a particle. Okay, now let us go for our next topic, that is point object. Now, what is point object? If the size of the object is very small compared to the distance it is going to cover, then we can treat the object as point object. Okay, if the distance the object is going to cover is very large and the size of the object is very small, then we can treat object as a point object. Let us take one example. Here the car is moving from point A to point B and the distance between point A and point B is 5 km. And we all know that the length of the car will be usually 3 meter to 4 meter. Now compare the length of the car with the distance it is going to cover. The length of the car is 3 to 4 meter, whereas the distance between A and B is 5 km. Now, if you are going to compare the size of the car with the distance, the size of the car is very small. So we can treat car as a point object. Okay, what is point object? If the size of the object is very small compared to the distance it is going to cover, then we can treat the object as a point object. Okay, I hope you have understood the concept of point object. Now let us discuss about the rest in motion of an object. Now, when the object is said to be at rest and when the object is said to be in motion. Object is said to be at rest if it does not change its position with respect to the time. Okay, when the object is going to be set at rest, it is said to be at rest only when it is not going to change its position with respect to the time. Let us take one example here. At 9 o'clock, the car is at 0th position. Now, after 20 minutes, that is at 9:20, the car is still at 0th position only. That is, even with the time, the position of the car is not at all changing. So we can say that car is at rest. Now what is motion? The object is said to be in motion only if it is going to change its position with respect to the time. When the object is said to be in motion, if it is going to change its position with respect to the time. Let us take the same example of the car. At 9 o'clock, the car is at 0th position. Now, with the time, the car is changing its position. Initially at 9 o'clock it was at 0th position. At 9:20 it is at 30th position. Okay, the position of the car has changed with the time. So we can say car is in motion. I hope you have understood the concept of rest and motion of the particle. Just now we have discussed about the rest and motion of an object. But rest and motion are relative. What this means? It means that rest and motions depends upon the observer and the reference point we have taken. To understand this better, let us take one example. Here you can see a train is moving on the track and four people are standing outside. For the person in the orange shirt here, all the passengers inside the train appears to be moving, whereas his three friends appears to be at rest. Why it happens like this? Because for him the reference point is earth. That's why the passengers inside the train appears to be moving, whereas his friends, three friends, appears to be at rest. Now, similarly, if you take any passenger inside the train, for that passenger, these four people will appear to be moving, whereas his co-passengers will be at rest because the passenger has taken the train as the reference point. That's why for him these four persons appear to be moving, whereas his co-passengers appears to be at rest. Now with this example, you might have understood that rest and motion depends upon the observer and the reference point he has taken. That's why we say rest and motion are relative. Okay, I hope you have understood the concept that rest and motion are relative. Now let us discuss about the frame of reference. Now, what is frame of reference? Frame of reference is a setup that we use to describe the position of a particle or to measure the motion of a particle. In mathematics, we use a rectangular coordinate system to measure the motion of a particle. Now, what is this rectangular coordinate system? As shown in this diagram, a rectangular coordinate system consists of three mutually perpendicular axes, that is x-axis, y-axis and z-axis. It consists of three mutually perpendicular axes, and these three axes will be intersecting at a point O. This point O is called as origin and it serves as the reference point. Okay, what is coordinate system? Rectangular coordinate system. A rectangular coordinate system consists of three mutually perpendicular axes as shown in the diagram x, y and z. These three mutually perpendicular axes will be intersecting at a point O, and this point O is called as origin and serves as the reference point. This rectangular coordinate system along with the clock constitutes the frame of reference. Okay, what is frame of reference? A frame of reference consists of a rectangular coordinate system along with the clock, and this setup is used to measure the motion of a particle or to describe the position of a particle. Okay, let us consider a point object P in a space at any point of time, and its coordinates are x, y and z. Okay, if any one of the coordinates of the point object P changes with time, then we say that point object is in motion. If none of the coordinates are changing, then we say that point object is at rest. Okay, based on the number of coordinates of the point object changing, there are three different types of motion. Let us discuss these three different types of motion. During the motion of an object, based on the number of coordinates changing, there are three different types of motion. One is one-dimensional motion, second one is two-dimensional motion, and the third one is three-dimensional motion. Let us discuss these three types of motion one by one. First, one-dimensional motion. Now, what is one-dimensional motion? In one-dimensional motion, out of the three coordinates, only one coordinate of the object will be changing. This type of motion is called as one-dimensional motion. In this case, the object will be moving along a straight line. Okay. In one-dimensional motion, the object will be moving along a straight line. Second one, two-dimensional motion. In two-dimensional motion, out of three coordinates, two coordinates will be changing. Okay, this type of motion will be known as two-dimensional motion. And in this case, the object will be moving in a plane. The object will be moving in a plane in two-dimensional motion. And lastly, three-dimensional motion. In three-dimensional motion, all the three coordinates of the object will be changing. Okay, all the three coordinates of the object will be changing in three-dimensional motion. In this case, the object will be moving in space. Okay, in this video session, we have discussed about mechanics and its branches, position of an object, definition of a point object. Also, we have discussed about rest and motion of the object. At the end, we have been through the frame of reference and different types of motion. In the next video session, we will be discussing about distance and displacement. Okay. As I have already told you that I am going to ask you one question at the end of this video, and you have to give the correct answer in the comment section. The question is, if two coordinates of the object changes, then object will be moving. Options are A along the straight line, B on a plane, C in a space, D none of the above. Okay, you have to give the correct answer in the comment section. If you want to follow my video series, then don't forget to subscribe my channel. If you think this video was useful to you, then share with your friends also. Thank you very much.